If you have a question describing a certain task being accomplished over a specific amount of time, you'll likely be using the formula that your rate times your time is equal to your distance. Or you could use the equation that your rate times your time is equal to your work. Your rate is simply a snapshot of how much work or distance gets accomplished for every unit of time that you're measuring. So when you say you drive your car at 60 miles per hour, that's your rate. And that simply means that every hour at that speed you would travel 60 miles. So in this question they give us the hours and they give us the total work being done. And what they're asking for is the amount we get done each hour. In other words, they're asking for our rate. So we simply use the equation of our rate times our time is equal to our work. Or in this case, our rate that we don't know yet times a time of 8 hours will be equal to a total work of 176,000 nuts. Then we simply divide both sides by 8, and we get our rate is equal to 22,000 nuts, or 22,000 nuts per hour. Many of your problems will involve comparing two trips or two works. So you can build what's called a rate table, where I'm still going to use the equation that my rate times my time is equal to my distance, and I'm going to be comparing trip 1 and trip 2. And then I'm just going to fill in the table the best I can. Generally speaking, there are 2 or 3 kind of rate problems. You can have a problem where you have 2 people starting at the same place and they travel the same distance. Those are problems where 2 people are traveling in the same direction. If 2 people are traveling in the opposite direction, then their individual distances added up will give you their total distance apart. Likewise, if they travel in opposite directions but head towards each other, the same rules apply, where you add their individual distances to get their initial distance apart. So usually in rate problems, you're either going to be setting 2 distances equal to each other or adding 2 distances to find a total distance. So here's a fairly classic situation. We've got 2 joggers, Scott and Garrett. Scott takes off first, and then a half hour later, Garrett runs after him. Eventually, Garrett overtakes Scott. And at that moment where Garrett passes Scott, they have traveled the exact same distance. Because I'm comparing 2 trips, I'm going to use my rate table, where I have Scott and Garrett, and both we're going to use the equation rate times time is equal to the distance. The question tells us that Garrett overtook Scott in 2 hours, so Garrett's time is 2. But Scott left a half hour before Garrett, so Scott's time is going to be 2.5. We don't know Scott's rate, but we do know Garrett is 1 mile per hour faster than Scott, so we could write his rate as Scott's rate plus 1. And then we calculate their distance. Scott's rate times his time is going to be 2.5 r. And Scott's distance is going to be r plus 1 times 2, or 2r plus 2. Because they travel the same distance, we could write the equation that 2.5r is equal to 2r plus 2. Subtract 2r from both sides, and we get 0.5r is equal to 2, where r is equal to 4. Now we have to make sure we're actually answering the question they're asking. They're asking us, how many miles did Garrett cover? And we could just plug that, our r, into Garrett's distance equation. So Garrett's distance will be equal to 2 times a rate of 4 plus 2. Or both Garrett and Scott total each have a distance of 10. In this problem we have a similar situation. We have 2 joggers. We've got someone who is fast and someone who is slow, but this time they start at the same point and they run in opposite directions. So that means to find the total distance they are apart at the end, we're simply going to add their individual distances. So again, I'm going to start off by building my rate table, where I have my fast jogger and my slow jogger, and we're using the equation that the rate they run times the time they run is going to equal their total distance. We don't know the rate of the slow jogger, but we do know that the fast jogger is 2 miles an hour faster than the slow. So I can call the slow jogger's rate just r. And the fast jogger will be r plus 2. They both run for 3 hours. So the fast jogger's distance will be his time, which is 3, times his rate, which is r plus 2. And the slow jogger will simply be 3r. So if we draw this out, the fast jogger runs 3r plus 6, and the slow jogger runs in the opposite direction for 3r. And then we know they are a total of 30 miles apart. So that means the 3r plus the 3r plus 6 must equal the 30. And that's my equation. 3r plus 3r plus 6 is equal to 30 miles apart. I can combine like terms and subtract 6 from both sides, and I get 6r is equal to 24, or the rate is 4. And the only trap here is to make sure that we're actually answering the question. They're not asking for the rate. Remember, that was our rate for the slower jogger. They want to know the faster jogger. So what we're really looking for is r plus 2 or 6. Sometimes you can have rate problems that, although they're not exactly motion problems with rate and time and distance, it's still helpful to visualize them as if they were a motion problem. In this case, for example, we have two salesmen. We've got Janelle, who's selling at $3,200 per day. That's her rate. And Carl, he's selling at $2,000 per day. So if we were to use the equation that rate times time is equal to distance, Carl's distance would be 2,000 times his time. And Janelle, she would be equal to 3,200 times her time. Now we look at what Janelle is trying to accomplish. She's starting behind Carl. In fact, she's starting way behind Carl. She's starting back by $60,000. So her goal is to catch up to Carl. And then she's going to have to make up all the distance that he's traveled while she was trying to catch up. So his distance is going to be 2,000 times the time he was working. And then Janelle wants to pass him by another 12,000. So we can see that Janelle's path has to go 60,000, then 2,000 t, and then another 12,000. And all of that is going to be equal to her rate times her time, or 3,200 times time. So you could write the equation that Janelle's 3,200 t will be equal to 60,000 to catch up, plus Carl's 2,000 t, plus an additional 12,000, or 3,200 t is equal to 2,000 t plus 72,000, or 1,200 t is equal to 72,000, or time is equal to 60, or 60 days. Janelle will catch up, pass Carl, and then exceed him by 12,000 within 60 days.